All right, my student wants to work on some social studies, and he doesn't need my help for that. So here I'm back. I'm back with you. Um, okay, so I did number 2. Let's take a look at number 3 here. We got radical 6 times radical 6. Okay, so let me put that in here. Radical. Oops, that's not what I wanted. Oh, I'm going to insert special character, square root. Symbol I want. Great, it's now in there. Great. Radical 6, and I'm just going to copy this. Control C. Now I can just keep pasting it whenever I want it. Okay. So radical 6 times radical 6, it's pretty easy, right? 6 times 6 is 36, so it's radical 36. But we know what radical 36 is, I hope. There's a number multiplied by itself that gives me 36. Think about what that is. Well, I'm hoping you're thinking, okay, well, 4 times 4 is 16. 5 times 5 is 25. 6 times 6, 6 times 6 is 36, which means that the square root, or radical 36, is equal to 6. It's just equal to 6, right? It kind of went back to becoming itself. And you'll find that happen. Any two radicals of the same number will just become the number without the radical. All right, okay, now it gets a little trickier. I've got radical 5 times negative 4 times radical 20. So radical 5 times negative 4 times radical 20. That's what I've got going on. Okay, well, technically, there's an invisible 1 in front of this radical here, and I can begin to multiply the like terms. 1 and negative 4 can be multiplied together. They're like terms, so that gives me negative 4. Negative 4 just goes over the end. Radical, now I multiply what's inside the radicals. 5 times 20 is 100. All right, maybe you got that math fact. Maybe you don't. Use your math machine if you need that. And then I'm done, right? Am I done? I'm done if I don't have to simplify. But if you want, if the instructions were to simplify here, and I didn't see simplification here, but eventually a math teacher is going to require simplification, so you might as well learn it now. Hopefully, you know that there's a number times itself that'll give you 100. What's that number? Yeah. Well, all right. 10 times 10 is 100. I think you know that. So then what do I really have here? I've got negative 4 times what's the square root of 100 equals 10, which means this whole thing just equals negative 40. Negative 40. Negative 4 times positive 10. A negative times a positive gives me a negative 40. All right, I think I will leave you with 5 and 6. Oh no, I do want to. I'll let you do 5. I think you can handle that. Tricky part here is there's a negative in front of the radical, so think of that as negative 1. Okay, and then I want to talk about 6. Radical 20 times x squared times radical 20x. Okay, because now we got variables going on. Okay, here we go. Number 6. Radical 20 x to the second power. I need actually technically when I'm working with radicals like this, since my it gets kind of why do I do this? Technically, this square root here might be interpreted as only applying to the number right next to it. So what I got to do is I got to put this whole thing in parentheses so that we know that the entire thing is under the radical. All right, there's like an implied parentheses going on here. That's all right. Unfortunately, we're struggling with the technology and we're trying to do math in one line here. And then I'll get 20x. All right. Everything? Did I get everything? Okay, I'm just checking to make sure I got everything. Okay. Don't be afraid. It's not that bad. The first thing is I can, since everything's under the radical, I can start multiplying everything in the radical. I'm going to take the 20 and the 20. Those things are kind of like terms in this situation. So I'm just going to multiply them together. If you don't know what that is, that's 400. So I'm going to have radical 400. That's 20 times 20. And what's x to the second power times x? What's x to the second power times x? Do you know what that is? You know your exponent rules, right? That's just x to the third. We just add the exponents when multiplying them, right? So this is technically just x by itself is x to the first. So there's like an invisible raised to the first power there that we don't always mention because it doesn't change anything. X to the first is just x. whatever that number is. So x to the second times x to the first is x to the third. We added our exponents together. So we're going to do that right here. I don't need this multiplication symbol technically, but I'm putting it in there just so you see what I'm doing. And then there's that. Okay. We would be done if we didn't have to simplify, but in case you're required to simplify, well, we know that this would be the same thing as radical 400 times radical x to the third. Right, I just broke those up. Into two different radicals, right? Okay. Now what can I do with this? With this 400? You know what you can do with 400? Take a guess. Think about it. Maybe pause the video if you need more think time. Well, 400 is actually a perfect square, right? And you may not know that. You may not know that. You just may need to get experience with this kind of thing. But like 18 times 18, right, is going to be 324. 19 times 19 is going to be 361. And then 20 times 20. You guessed it. That's 400. All right, which is the same thing as 20 raised to the second power is 400. So that would mean that the second square root of 400 would be 20. All right, 20 is the number when I multiply it by itself gives me 400. So the square root of 400 is really the same thing as 20. And this is tricky. What is the square root? I didn't want that number 5 there. What is the square? It's going to put the number 5 there no matter what, apparently. Okay, there we go. What is the square root of x to the second power? What's the square root of x to the second power? Take a guess. Well, I hope you know that if I take the square root and then I raise something to the second power, I'm just going to get x. All right, let me kind of give you a feel of how that is. What is x times x, huh? That's going to be x raised to the second power. Same idea as x to the second power. What is the square root of x to the second power then? Well, what we're really asking here is what number times itself would give me times itself and then square rooted. What would that give me? Well, the square root cancels the raising it to the second power. Like raise the second power multiplies it by itself, and then the square root question symbol says, well, what number would it be if it was multiplied by itself? So that's just x, right? That's kind of how that works. Okay, now we have a little more complex thing going on here because we have x to the third, right? We have radical. I hate that 5 that keeps popping up. Radical x to the third. Well, what's that? Well, technically that's the same thing as radical x to the second times radical x, right? Technically if I know that this is really just equal to x, that means that radical x to the third is really the same thing as x times radical x. And so I have that right here. I have the square root of x to the third. That's going to be the same thing as the square x times the square root of x, which after I get done and simplify everything, that means it's 20x times radical x. And I'm done. Oh my gosh. Okay. That's kind of how you play those games with the variables and the x's. All right. Let's see. I'm going to deal with like maybe, I'm trying to figure out which one's harder, 9 or 10. I'll go with 9. 9 looks complex. There's a lot going on. Let me do 9. And then you can do the rest of these. All right, well, that's going to be tough to even get down. Negative 3 times radical 7r to the third. All right, negative 3 times radical 7r to the third. Negative 3 times radical 7r raised to the third. And technically, I might, since I'm doing straight line math here, I need a parentheses to indicate that all of that whole expression is under the radical. Okay. And then I have times 6 times radical 7r to the second times 6 radical 7r to the second times 6 radical 7r raised to the second. Technically, I need those parentheses in there again. Okay. I think I got it. I think I got everything in there. All right. Yes, there's a mess of stuff here going on. Let me start with what I can start with. Oop. All right. Let me first multiply what's on the outside here. So I've got that 6 is like a like term to the negative 3. I can multiply those pretty easy. Negative 3 times 6 is negative 18. All right. 3 times 6 is 18. Negative times a positive is a negative. Negative 18. And now I got to multiply everything that's inside the radicals. Okay. I'm going to start with the 7. Start with 7 times 7. All right. 7 times 7 is 49. R to the third times r to the second. Remember those exponent things? It's going to be, if you want to think about it, r to the third, r raised to the third is the same thing as r times r times r. And then r to the second is really the same thing as r times r, right? Which means if I'm taking, r to the third times r to the second, what I'm really doing is r times r times r times r times r. 5 r's, right? Which is the same thing as r raised to the fifth. That's why we have these exponent notations, because it's a lot easier than saying r times r times r times r, right? Just r to the fifth. Okay, so I have r to the third times r to the second is r to the fifth power. Added the exponents. Okay, everything looks good. Now it's just simplification time. Well, I can break this up a little bit. I can say this is the same thing as radical 49 times radical r to the fifth. All right, equals. Well, I know what the square root of 49 is off the top of my head. Do you know? Think about what number multiplied by itself gives me 49. Maybe you want to pause the video, give it some think time. Hopefully your brain is screaming 7. 7 times 7 is 49. All right, okay. Well, then that's negative 18 times 7, right? Negative square root of 49, same thing as 7, times the square root of r to the fifth. Well, I can begin to just simplify this part, right? That's just a math thing. Negative 18 times 7, I can multiply those things together fairly easy. Negative 18 times 7 is negative 126, right? Negative 126, okay? And it's still times, got that annoying radical r to the fifth here. Okay, I gotta think of how am I gonna square root r to the fifth? Let me think about this. R to the fifth is really the same thing as r to the fourth times r to the first, but that's r to the first is really the same thing as r. So it's up to you if you want to keep the to the first, or sometimes it makes more sense to keep the one in there. That helps you remember what's going on. Mathematicians, we just drop the raising to the first power thing, as doesn't matter, right? It's like one of those invisible things, but sometimes it helps to understand what's going on. Well, if I'm trying to take a square, so what if I had the square root? If I had the square root of r to the fifth, then I have to turn this into the square root of r to the fourth times the square root of r to the first. Well, I can't do anything with square root of r to the first. That's done. I don't know what r is, so I don't know what the square root of it would be. But I could play with the square root of r to the fourth, right? Because what is the square root question asking you? It's asking you what number multiplied by itself would give me r to the fourth. Well, r to the second times r to the second, that's number times itself, would give me the fourth, which means the square root, I don't like that 5 that keeps popping up. It's not my friend. It keeps popping up. Okay, which means r to the fourth, I could simplify that. It's just r to the second, right? Because I know that r to the second times r to the second, a number times itself, would give me r to the fourth, all right? So this r, the square root of r to the fourth is really just r to the second. All right, so over here, back to, I have r to the fifth, and I now know that r to the fifth is the same thing as, or my r to the fourth. My r to the fourth is the same thing as r to the second times the square root r to the first power. Your call. All right, so now I'm back over here. Let me get my numbers in here. Negative 126 times r to the fifth is really the same thing as r to the fifth. We discovered is really the same thing as r to the second, right, times radical r. And in math, we don't always need, we can do, there's it called implied multiplication. We put a variable next to a number, implied multiplication going on there, and technically there's implied multiplication in front of that radical. I don't need that asterisk, but if you like them, go ahead. No, what I do? Oh, it went to the other side of the, the line, and I got scared. Right, so I don't need the asterisks, but if you like them, go ahead and put them in there. It doesn't hurt anything. It just makes it more busy. All right, that's where I'm going to leave it. It's on you to go hit up 5, 7, 8, and 10. All right, that's still enough to practice, and hopefully that gives you a good start.